In section 11.5, we're going to look at solving equations that are reducible to quadratic. So that's the title of the section. And what we mean by equations reducible to quadratic is this. Let's say I'm going to take a look at this section. The general form of quadratic equation we know is in this form. So it is possible to have equations that may not look like they are quadratic, and in fact they're not. But underneath what we see here, it somehow turns out that we can rewrite these equations in quadratic forms if we wanted to, and then work them as quadratic equations. So that's what we want to do. Now, in section 11.5, let me go to page 731. That's where your homework is, and let me again flash the homework pages for those who need to possibly take a picture of the homework page. But this is section 11.5, and our focus is primarily on this side, exercises 11 through 29. And of course I do have on the following page, page 732, I may have an exercise on this next page also. Our focus is primarily on this segment right up here, primarily this area. All of these equations, again, if you just browse through these equations, through the list, none of these look like quadratic equations from the onset. If I go to previous page, page 731, they don't look like quadratic equations either, the ones that are in this segment. Again, we're looking at this segment here. So how are we going to solve these equations? I went ahead and I picked one exercise for you to look at. And the way we're going to do this, we're actually going to do this using two methods. So I have method A, and then I have method B here. Method A requires that we introduce a new variable. This new variable could be anything you want to call it. I just called it x. So I'm going to let x be t squared. Now, what tells me that I should do that? The hint is the term that's in the middle, in the original equation. You see that middle term right up here? T squared. Usually the new variable that you want to introduce is going to be what's in here. So I'm going to let x be t squared. Well, if that is the case, then we know if I square both sides, x squared becomes x squared, and t squared squared becomes t fourth. And now with this substitution, I can replace t to the fourth up here with x squared, and that's what I've done here. And then the negative 11t squared becomes negative 11x, because x is t squared, and then plus 18. The next step actually involves factoring. And remember, to factor these quadratic equations, usually the way the factoring goes is we need two numbers that multiply to 18, and they add up, same two numbers add up to negative 11. So I have negative 9 and negative 2 as those two possibilities. The product, positive 18, and the sum is negative 11. The next step, I apply the zero factor property. So I wrote x plus 9 is 0, or x plus 2 may be 0, and simply solve these. These are simple linear equations you can solve. Add 9 to both sides here, add 2 to both sides here, and you get the solutions. Now remember, these are the solutions to variable x. So what I need to do is I need to back substitute for x up here and solve for t now. And that's what I've done down here. So I have t squared is equal to 9. And took the square root of both sides to solve for t here. X equals 2, back substitute x again all the way up here. X equals t squared. And when you do, you get this equation. And again, by taking the square root of both sides, we can solve that equation for t. So it looks like we have four possible solutions for this fourth degree equation, polynomial equation. So this is one method, method A, which is in the book, and again, using this method, in effect, we were able to reduce this equation. Okay, let me go here and actually highlight it. There you go. We were able to reduce this equation into a quadratic equation, and hence the title of the section, Equations that are Reducible to Quadratic. Now, the other method here is to actually employ factoring method right off the bat. So instead of introducing this secondary variable, I'm just going to go right to factoring this. And when you usually factor these expressions in this section, your first term, you're going to let it be again the middle term t squared. Don't worry about the number, just the variable t squared. So in here, I went t squared minus 9t squared minus 2. If you FOIL this, t squared gives you t fourth. Negative 2t squared, negative 9t squared combines to negative 11t. And negative 9 times negative 2 gives you positive 18. So that is the factored form. And then you set each factor equal to 0. Here, add 9 to both sides. The other one, add 2 to both sides. Take the square root of both sides, and we get plus minus 3 on one side and plus minus root 2 on the other. And notice we get exactly the same solution as the other one. And right up here, look at the factored form here. Look at the factored form for the reduced equation. They kind of look the same. Here's x, here's t squared. Remember, we let x be t squared. In our next exercise, this is exercise number 24. So we have s plus 3 root s minus 40 equals 0. So I'm going to let x be square root of s. Remember the middle term? That's what we want to let it be. And then if that is the case where x is root s, then I can square both sides. And squaring both sides gives me x squared equal root s squared, which becomes just s. Now I'm going to replace s with x squared. Replace square root of s with x. And now I have a reduced equation that is in quadratic form. We can factor this one, which I did. These are the factored form. And you solve each factor, we get two solutions out of this work. X is negative 8 and x is 5. And then we need to go back and substitute for x. I plugged in negative 8, and then another time I plugged in a 5 for x and solve for s. Now remember, the symbol, square root symbol, means principal root or positive root. It cannot equal to a negative number, so because of that, there's no solution in this equation. The only solution comes out of this one. So in this one, I have square root of s equal 5, which I square both sides of that, and I get s is equal to 25. And there you have it. That would be the solution to the original equation up here. Now, if I go the factoring route with this one, again, the factored form is going to be the middle expression, the term without the constant, the middle term right in here. That would be my first term here. So I'm going to have root s, and then two numbers multiply to negative 40. 8 times negative 5 makes negative 40. The sum of 8 and negative 5 gives you the coefficient on the middle term, which is a 3. And then each factor, you set it equal to 0 here. So you move 8 to the other side of 0, so square root of s should be negative 8. Move negative 5 to the other side of 0 becomes 5. And then by the same reasoning, because you have a negative, what do you call it? You have a negative answer to the square root right in here. That's not going to be acceptable. So there's no solution to that because we want the positive root. And then the other one, just like before, root s is 5, you square both sides and it becomes 25. And of course, again, your solutions, we don't expect different outcomes. It's just how we went about it was different. So you can use factoring, or you can actually reduce the equation to quadratic and solve it using quadratic expressions, quadratic factoring. Our next example, I believe it's the last one. That's our last example in this section, is number 33. In number 33, the expression is t to 2/3 plus t to 1/3 minus 6 equals 0. So again, our routine, I'm going to let x be t to 1/3. So now when I square both sides, x becomes x squared. T to 1/3 squared Using the power rule of exponents, you multiply 2 times 1/3 becomes 2/3. So that's t to 2/3 now. And this becomes x squared plus x minus 6 equals 0. And next step is our factoring step. So we go x plus 3 times x minus 2 equals 0. And by zero factor rule, x plus 3 is 0 or x minus 2 would be 0. So x is negative 3 and then x is 2. Again, we need to back substitute for x up here and solve for t, because t is the original variable, not x. And I did. So here's x, and remember x is equal to 2t equals 2t to 1/3. Next step, I cubed both sides. Negative 3 cubed makes negative 27. T to 1/3 cube, that becomes just t, and there's one solution. The other solution is when you plug in a 2 for x, and then I cubed both sides of that. 2 cubed makes 8. T to 1/3 cubed, 3 times 1/3 is 1, and that's just t equals 8. That's by introducing again a secondary variable x equal t to 1/3. We can also go factoring route, and here's the factored form: t to 1/3 plus 3, t to 1/3 minus 2. Again, two numbers that multiply to negative 6, right? Remember up here, two numbers multiply to negative 6, that's 3 and negative 2. And the coefficient on the middle term, t here, t to 1/3, it's not there, so it's really a 1 that's not written there. 3 minus 2 becomes 1, so that's the right combination here. And then again, we said each factor equals 0. Move 3 to the other side of 0 becomes negative 3. Cube both sides, we get the same results. T to 1/3 minus 2, move negative 2 to the other side becomes 2. Cube both sides, 2 cubed 8. T to 1/3 cube is t. And there you go, we have solved this equation also. And that is how we solve equations in this section. Again, you can use factoring, or you can introduce a new variable and write the reduced equation as a quadratic equation and solve it. And with that, we are done with this section.